We did our project on catalytic converters, and the people who worked on this project were Mason, Sam, Cade, and Gus.
Okay. In the early 1900s, there was a great deal of industrialization that led to increasing amounts of smoke and fog in the atmosphere. The smoke and fog was coined into a word we all know now as smog. Smog is a thick, orangish haze that causes a lot of problems for people. Basically, it produces harmful chemicals like nitric oxide and ozone. It also causes breathing problems, eye irritation, crop damage, and even acid rain when nitric oxide molecules mix with oxygen and water to create acid. This acid rain can poison water supplies and cause property damage, which is obviously not good at all. One of the effects of smog can be seen here in the picture on the right. It was taken from the columns of the Parthenon in Athens, Greece, which is one of the most traffic-polluted cities. As you can see, the columns have been blackened by vehicle pollution, which is indicative of the problems that industrialization pollution has caused. Also, it just looks plain ugly.
In 1990, the Clean Air Act required that all automobile manufacturers install catalytic converters to comply with emission standards. The Clean Air Act was first enacted in 1955 with major revisions in 1970, 1977, and 1990. The Clean Air Act requires the Environmental Protection Agency to set health-based standards for ambient air quality and set deadlines for the achievement of those standards by state and local governments. It also requires the Environmental Protection Agency to set national emission standards for large or ubiquitous sources of air pollution, including motor vehicles, power plants, and other industrial sources. The Environmental Protection Agency mandates emission controls for sources of 187 hazardous air pollutants, many of which originate from combustion engines, including nitrogen oxides and carbon monoxide. It requires the prevention of significant deterioration of air quality in areas with clean air and contains a program to restore visibility impaired by regional haze or smog in national parks and wilderness areas. The Clean Air Act also implements the Montreal Protocol, an international treaty signed by the United States to protect the ozone layer to phase out most ozone-depleting chemicals. Catalytic converters were originally added to cars around this time to help reach these goals.
A catalytic converter is essentially a component in a car that works by purifying harmful engine emissions with a honeycomb complex chamber. This honeycomb chamber is coated with a layer of platinum, rhodium, or palladium. The purification process happens via redox reactions that reduce harmful compounds such as nitric oxide, nitrogen dioxide, and carbon monoxide into harmless compounds like water, carbon dioxide, and nitrogen gas. Now you might be wondering why the converter is made out of a honeycomb chamber. So the honeycomb chamber is actually designed to give the most surface area possible for the redox reactions to happen. It also allows air to go through it relatively smoothly, which is obviously ideal for car engines that need to get rid of their gases. You also might be wondering why the converter is usually made out of platinum, rhodium, or palladium. Well, on top of, actually being the things that catalyze the redox reaction, these three elements are noble metals, which are excellent at resisting corrosion from the chemicals that are released from said engine. So basically, this allows the catalytic converter to last a long, long time.
Oxidation reactions occur when an atom loses an electron, a negatively charged particle, and reduction reactions occur when an atom gains an electron. The transfer of an electron from one species to another is called a redox reaction. These reactions were originally named like this because they sometimes occur with atomic oxygen, and especially in cases with practical applications. In the example above, the electron from the A oxidation reaction would cancel out with the electron from the B reduction reaction. Each half reaction could combine to produce one redox reaction. So A and B plus yields A plus and B. An example of a redox reaction is a thermite reaction where solid iron 3 oxide reacts with solid aluminum to produce aluminum oxide and liquid iron metal. Catalytic converters use redox reactions to break down dangerous molecules into their inert gaseous states, which we see examples of in the next few slides.
Daily, people are exposed to nitrogen oxides, which include nitrogen monoxide and nitrogen dioxide, among others. Low-level exposure is not that harmful to humans, but high levels of exposure can irritate the skin through contact and the respiratory system through inhaling it. Nitrogen monoxide specifically is a colorless gas with a sharp, sweet odor. Nitrogen dioxide is a yellow gas with a bleach-like smell. Symptoms of exposure are coughing, wheezing, difficulty of breathing, and the development of asthma. Because of these, children and the elderly are the highest risk populations of nitrogen monoxide poisoning. During the first stage of the catalytic process, the platinum and rhodium covered parts of the honeycomb structure capture the nitrogen from the nitrogen oxides, and the leftover oxygen binds to free oxygen to make O2 gas. The nitrogen molecules then react with each other to form nitrogen gas, which is emitted through the exhaust. Nitrogen gas is still harmful to humans with high exposure because of its affinity to bond and replace oxygen in breathing, leading to suffocation. At least nitrogen gas doesn't have the chronic side effects and is low exposure as nitrogen oxides do. Carbon monoxide is a harmful gas. It is colorless and odorless. It is dangerous because it more readily binds to the hemoglobin in our blood, stopping oxygen from binding. This can lead to suffocation. Symptoms of carbon monoxide poisoning are fatigue, headaches, confusion, dizziness, and even death. Hydrocarbons are extremely harmful substances. They are found in many objects, such as paint thinners, motor oil, and lotions. Hydrocarbon poisoning is the most commonly caused by inhalation of the gaseous form, but the solid and liquid forms can be ingested. Hydrocarbons can affect the respiratory, cardiovascular, gastrointestinal, and nervous systems. Pulmonary toxicity is the most common, though. Symptoms of hydrocarbon poisoning can be seen in many parts of the body, but the pulmonary symptoms mainly develop from the damage of the alveoli by the physical gas itself. Both carbon monoxide and hydrocarbons go through an oxidation reaction in the second phase of the catalytic converter. Here, they are converted into much less harmful carbon dioxide and water.
There are many advantages pertaining to the use and development of catalytic converters. By reducing emissions, catalytic converters improve air quality, thereby reducing the risk of health problems related to air pollution. Catalysts offer the opportunity to directly convert toxic molecules in water to non-toxic products. Like catalytic converters used in cars to break down gaseous pollutants from fuel combustion, small catalysts can be used to purify water as well. Innovations in catalytic converter technology, such as three-way converters and palladium, platinum, and rhobium reduction, or PGM reduction, can improve efficiency and reduce the cost of production. Benefits of these innovations include reduced emissions, improved fuel efficiency, and increased durability. Catalytic processes may be a competitive alternative to conventional water treatment technologies. They have much faster kinetics and are less operationally sensitive than current bioremediation-based methods. But catalytic converters do not always work perfectly. There are numerous downsides to catalytic converters, and here are some just to name a few. Sometimes they may not always be effective, and not all pollutants can be dealt with via the converter's chemical reactions, and some pollutants can still escape into the environment. When catalytic converters fail, they can produce even more pollutants sometimes. Signs of a catalytic converter that needs to be replaced can include a smell of sulfur from the exhaust, dark exhaust smoke, or extreme heat coming from underneath the vehicle. Pertaining to cost, research in atmospheric chemistry has revealed that the composition of exhaust is more complex than originally thought, and multiple stages have had to be added to catalytic converters to remove different pollutants, which unfortunately increase their cost as a result. Catalytic converters require precious metals like platinum and palladium in order to function as well.
Electric vehicles don't require catalytic converters because no combustion reaction occurs that could produce harmful gaseous pollutants. If we continue to use combustion engines, the catalytic converters of the future could be upgraded to last longer and require fewer rare materials in order to operate effectively. One study from the U.S. Department of Energy's Advanced Photon Source, APS, identified structures of rhodium aluminate, an inactive compound in catalytic converters, resulting from exposure to extreme heat generated by other automotive components. At these high heats with oxygen exposure, rhodium dissolves and degrades into the stable compound rhodium aluminate. This compound, however, is chemically inactive, meaning that it can't scrub away harmful pollutants and gases, acting as a catalyst, making the device effectively useless. But this reaction, importantly, is reversible. When exposed to hydrogen, some of the rhodium becomes active again, but not nearly enough to return the catalyst converter to its former efficiency. The results of the study concluded that a new design that prevents the formation of rhodium aluminate could help get the most out of these devices in the long run, or reverse the reaction more completely and restore the catalytic converter to its original efficiency.
Here are our results.